Hey there, greetings everyone. Daniel Lowrie with Antisyphon Training, and I'm back. I'm back with another episode in our Networking Fundamentals series, and today we're going to put the fun back in the fundamentals because we're looking at firewalls. We're going to try to figure out what is a firewall, what does it do for us, and how does it do those things? What are the different types of firewalls that I need to be familiar with? That's all in today's episode, so let's get cracking because there's quite a bit of information for us to go over. And of course, your boy Vibe coded himself another infographic for us because that is a helpful thing for us to kind of move along with the information and make sure that I cover all the things necessary in today's episode. This one is Network Firewall Fundamentals, your digital gatekeeper for network security. And that does break out to that first question that's burning in our minds. What is a firewall? And a firewall, right here, it says it's a security device. Could be hardware, could be software. It is something that monitors and controls network traffic. It is looking at things and is making decisions to allow or deny that traffic based off of rules that we set up as the end user. So that's all the baked in little information right here with what is a firewall. It's just a hardware. It typically is a hardware device, but a lot of times you will see software firewalls as well. And it's doing that monitoring and controlling of that network traffic. And I put ingress and egress over here. We're going to get to more of that in just a bit. And of course, we create the rules. We create the policies that say, this is good traffic, let it in. This is bad traffic. Es no bueno, make it stop. Moving on, understanding the core concept of a firewall and how that works. To me, it's like a traffic cop, right? A bouncer. A lot of anything that does some sort of control over, I like the idea of a traffic cop really well because you can see traffic, right? Cars moving from one end to the other. The police person standing in front of them go, no, you stop here. I'm going to allow this traffic to go. I'm going to make this traffic stop. It is that very idea. I also like the one of a bouncer standing at the door. They've got a list of approved people that are allowed to come in or whatever. And then anybody that's not on the list, as they like to say, your name's not on the list. And then you don't get access to the club, okay? So firewalls decide which traffic is allowed and which traffic is blocked. So I talked about it before, ingress traffic versus egress traffic. Ingress is simply just data or traffic that's coming into your network. Egress traffic is data going out of your network. Here's a little diagram of what that looks like. This is my best representation of a globe for the World Wide Web or in the internet. You can see this red arrow trying to make its way into your computer, your host, your network device. And it's saying, no, that traffic coming into that device, I'm going to block it. Okay? So that's data going into your, so maybe downloading a web page, right? Even if I've made that reach outs to a site and say, you know what, I need to download that specific item, or I just want to view your website, the firewall might say, well, we don't allow that. So I'm not going to, you might make the request, but I'm not going to allow the traffic to come back in. So that's ingress traffic. Then there's egress traffic. This is data going in, from your PC to the internet, out of your network. Could be going to other networks, but you get the idea. Typically, we're doing stuff on the internet. So this is data going out. Maybe you're sending an email, something like that. So where do firewalls sit? This is like I said, typically this is a hardware device. So there are a couple of different places in where this firewall could be positioned because it does need to see that traffic coming in. All the incoming traffic needs to, at one point, flow into this. And of course, anything that's outside of that is not going to reap the benefits of the firewall being able to look and see, is this traffic malicious? Is it something that we just don't want because there's no reason for it? Could be just scanning, could be whatever. But if you're not inside that firewall, if you're not on the other side of it, where its blocking capabilities are going to be most useful, then you are at more risk. So most of the time we set this on the perimeter. That's what we have here, the edge, the internet gateway, right? So there's your internet right there in this little circle. There's your firewall in blue. And you see that it's got blocked traffic and it's got allowed traffic. That's the red and the green. And this square with all these little gray dots in them, that is our internal network. So it is acting as the gatekeeper of all internet traffic, all outside traffic coming in. It's looking at the rules and saying, is this allowed? If it's not, then we're going to we're going to stop it. If it is, then we'll allow it. Okay. So then we also have internal segmentation. Maybe I want to separate two parts of my network out and make sure that traffic from one side doesn't make it to the other. So that could be a useful way in which we can employ a firewalls to stop traffic from one area of our network to the other and filter that stuff out, right? Firewall separating different departments or zones within an organization. And then this takes us to our host-based firewalls, right? That we're coming from the internet, and you'll notice there's no blue firewall here. It's actually on the device itself. That's a software-based firewall. That's something that it's sitting on the host, showing you how to do this. And I actually brought up the Windows firewall. This is the Windows Defender firewall with advanced security. And if we get kind of zoomed in here, you can see that we have inbound rules, we have outbound rules, and we have monitoring going on. All the telltale signs of a good firewall. Those inbound rules are going to be that ingress traffic, stuff that's coming in. All of these are rules that with the green check marks, and if you look over here with the action, it is showing you that these allow rules. These are things that it is allowing in. We can scroll down and see if there's anything that's specifically being denied. These are all the default rules in the Windows firewall, but you'll notice that this is all just allowing things. Okay? Now, we could be making deny stuff, but right now we're just making a allow stuff. Like we're allowing things to come in. These are typically called allow lists or whitelisting. You have deny lists, which are blacklisting. We're saying these are the specific things. And just depending on what philosophy you want to take, and you can do both, right? Like what we see here is, at least with inbound and outbound, maybe you go one way, maybe you go the other. It's all up to you on how that works. But I did want you to see that, and we can create new rules, and we will come back to that momentarily. Okay, so let's jump back over. So now that we know where these things can sit, what are we moving on to next? Well, we got a few concepts that we need to understand when it comes to the firewalls itself. And I wanted to make sure that we got these because I didn't want to forget them. And these are these key concepts. Rules and policies. These are the instructions for traffic. I think we've probably made that clear. I haven't used the word policy, I don't think yet. I've been saying rules because that's more typical, but it is a policy. Sometimes you hear them as access control lists, and that is a very simplistic form of setting rules for your firewall. But it's basically, at the end of the day, your rules or your policies are the instructions for how the traffic is either blocked or allowed. Then you have this idea. This is a philosophy that you can implement as a policy, which is default deny. Block everything unless it is specifically allowed. That's an allow list style. So maybe you want to just say, you know what? The best way to go about this is probably just deny everything by default. And then when people complain about not being able to access stuff, we know that we should allow that, and we'll make a specific rule to allow that traffic. And that way we do not miss anything, because if you go the other way around where you allow everything and only deny specific things, well, now you got to be really on top of what you're supposed to be denying, which is an ever-changing thing. So it's really difficult. Those goalposts are moving constantly. So it's difficult to stay on top of what you should be allowing if you go that way, if it's all allowed, only denying specific things. So it's easier and probably more effective to just deny everything by default and then allow the things you know are legit. And don't worry, if you're one, will we catch it all? Someone will complain if it's not allowing. They'll be like, I am trying to use this program and it can't work. It's telling me maybe it's a firewall rule. That is typically right. So then you'll know about it because the users will complain, which might be you. All right, then we have the ideas of stateful versus stateless firewalls. This tracks connections versus treating each packet individually. So stateless firewall just says, hey, I've got a rule of if it's coming from this source or this destination, or it's going to this destination, or it's looking at this type of traffic, maybe it's TCP traffic or it's UDP traffic, and it's going to this port, block or allow, whatever I'm going to do. Stateful firewalls, on the other hand, look at the connections. Is this a legitimate connection? If it is, then I can allow it. If it's not, well, then I'm going to block it. So it's a little more intelligence going on there. But you do need to be familiar with both stateful and stateless firewalls. All right, and that brings us to the idea of types of firewalls, right? So starting off with those type 1, first gen packet filtering firewalls, examine basic packet info, what IP, what port, what protocol, right? Going to the idea of that bouncer, right? Checking IDs. Let me see your ID there. Yep, 21, cool. Go on in. We get that ID. Yeah, 21, cool. We get, oh, you're 19. You can't go. I'm sorry. Nice try. You're old enough to, do other things, but this ain't it. So here you go. Enjoy your night. And they deny access. That's the same idea of a standard packet filtering firewall. So just keep that in mind. They are simple, they're fast, they're low cost, a lot of pros to them. They're built into a lot of firewalls by default, but there are some cons, some limitations, right? They have limited context. They don't really know what's going on. They're vulnerable to spoofing. They have zero application awareness. So these are very basic firewalls. So you just got to keep that in mind when you're employing them. That doesn't mean they don't have their area. They don't have their space. You just have to know that it might not be everywhere. You might not just get away with using these. You might need something more robust. Let's get back to it. And if we look, we see we have stateful inspection firewalls, 2nd gen. Yay, we're going to maintain a state table and track active connections. If I have a browser, I make a connection to a web server out on the internet, it's tracking that connectivity. Hey, something from the inside requested traffic from the outside. It's establishing a connection with something outside of here. I'm going to make a little note of that. I'm going to write that down. That seems interesting. So when that traffic makes its way back and it tries to return the request that was given, it doesn't go, well, what is this, buddy? It doesn't have to. It knows that that's a legitimate connection and that state should be allowed. If some random site decides to send you traffic that you have not requested, it's going to go, oh, what's that you got there? You're a cutie. But no, thank you. And it'll block it because you don't have a connection. You don't have anything that makes sense for it to allow that traffic to go through. Right? So there's your analogy of a bouncer who remembers who entered. So Bob and Sally go to the club last night. They got their IDs checked. Bob and Sally go in, they have a great time. Bouncer wishes them a happy day as they leave. Next day, they show up again. He doesn't have to check their IDs anymore. He knows who they are. He's already done the work. Same idea, right? The pros are it's more secure than packet filtering and better performance for established connections, right? Because it doesn't have to keep rechecking things. It knows those connections. It's already done the hard work. The cons are it's a little more complex and it's still limited in its application visibility, okay? Let's keep going. Proxy firewalls, interesting stuff. This is 3rd gen things. Acts as an intermediary, inspecting traffic at the application layer. So you might see this as an application layer firewall. You hear that. The analogy now is of a concierge who handles and inspects requests. Yes, Mr. Bill. Yes, Miss Sally. Let me get that for you. They make the requests and the concierge does it for them. Just like a firewall. If I wanted to get to a website and I wanted to get that traffic, I would make the request. The proxy would intercept that request, look and see where's it going, what kind of content, what's happening, is anything in there on the deny list? Does it make its way through that? If it does, cool, grabs the thing, brings it back, and then hands it to us. Does that make sense? So it's a proxy. That's the idea of a proxy. So pros and cons. Deep packet inspection, we like. Application-aware filtering, very cool. But the cons are performance overhead. You're going to hit some latency with these things just because it's doing a lot under the hood, checking all these things. And it is application specific. It's got to know about these different applications and what kind of traffic, because it does a lot of content filtering, okay? So when you think proxy firewalls, a lot of times you're thinking of the idea of A, it doing the requesting for you, and B, filtering based on content. All right, 4, next-gen firewalls, NGFWs. Combine traditional functions with advanced features like IPS, which is intrusion prevention systems. You have application control and threat intelligence. These are the big dogs on the block at this point in time. The analogy is a highly intelligent security system with behavior analysis. They're like the FBI's BAU. They're like, well, I'm watching and I'm profiling everything that you do, and I'm building a profile of this seems like malicious activity. And because of that, I can actually stop it because it probably has intrusion prevention capabilities built in. So it is vastly superior in intelligence sophistication when it comes to what it can block because of what it can understand when it comes to your traffic. Very cool stuff. Has its pros and cons, though, like anything. Pros, comprehensive security. Protects against modern threats. This we like. Cons are, it is more complex. Much more complex. So getting those things tuned just right is a much harder. Higher costs, going to cost you a bit more money. And it's also going to be resource intensive. That's why it's typically an application like an actual box, physical box, has its own dedicated CPU, RAM, so on and so forth. You rack and stack that thing, connect everything up the way it's supposed to be, and then you should be good to go. Okay? All right, moving on. How a firewall works, or how firewalls work. Rules and policies, right? Been talking a lot about rules. We need to kind of get into how those rules work. You've probably picked up a little bit so far, but let's hit the highlights here. Firewalls process rules in a specific order, typically top down. It means it's got a list of rules. It starts at the top and works its way through each one of those rules. If whatever the traffic is and its context and all the little bells and whistles about it, if it hits on any of those things, then it will key that rule to go into effect. That could be an allow rule. That could be a deny rule, right? And that's the important thing. If I have an implicit deny, if I have a deny by default policy where rule number one that I created was deny everything, now I need to build another rule that goes above that rule that says, well, if you're going to our web server, you can allow that. So then it looks at the traffic. Where is this headed? What's the destination? Is it the web server? If it's not, it doesn't meet the criteria and it discards the packet or it denies the packet. Is it headed for, okay, it is HTTP traffic. Is it headed for the right port? Is it TCP, right? Does it meet all the criteria that I have set to allow for access to the web server? If it doesn't, it's getting dropped. If it does, well, come on in, enjoy web services, right? So you got to remember, it's always top down. Well, not always, but most of the time you're seeing that top down, starting from the beginning and setting those rules in the right order. If you're going to get someone that's calling you and saying, I'm having trouble accessing the web server, we need to take a look at their request. What's going on? What are you doing that would stop this? And let me do the analysis of how does that line up with the rules that we have in place? And why is it getting popped? Why is it getting denied? And maybe you need to make an adjustment, right? So there you go. So it's going to match rules and then take action. Anatomy of the rule. Things like source. It could be the source IP, the specific host's IP itself, or just the network that they're from. We could be allowing or blocking things based off of the network that they're on, or the specific user that is sending traffic if it's going to be application aware and things of that nature. Destination, IP, again, same idea. Okay, where's it going? Where's it coming from? Who are you? Give me your IP. Tell me what network you're on. Tell me what service you're using. And I can block any of those things or all of them. Protocol. What protocol are you using? TCP, UDP, ICMP, you name it, it could go on there. What port are you looking to get at? Port 80, 443, 22, typical web, typical SSH, maybe it's RDP 3389, any of these things. And I can control with my firewall based off of what it is you're looking to do. And of course, what action do we take? And I want to camp out here for a second because we've got three different actions. We've got allow, deny or reject, and drop. So allow, simple, straightforward. Go ahead, enjoy. This is for you. I'm happy to allow it. Then you've got deny or reject and drop. Okay, what's the difference? It seems like either of those things would be, if anybody was trying to access something, they would not get access to it. And you'd be right about that. But there's a specific difference between the two things that you should be aware of. So if you're looking at a deny or reject, it's actually going to tell the user in some capacity, in some way, depending on how you're trying to make access, that there was an error. You're not allowed to access this. This is denied. You cannot go here. It's going to respond to the request. Whereas drop, it just ignores it. It just goes, packets on the floor. I don't acknowledge them. They're just nothing. And you might be wondering, well, who cares? Well, what does it matter whether I tell them they've been rejected or if I just drop the packets on the floor and give them nothing back? Could be that if you tell them you're rejecting their packets, they know that they're hitting a firewall. And if they're an attacker, now they can start trying to figure out a way around the firewall if that's at all possible. Whereas if you just drop it, it could confuse them a little bit and say, okay, is this just a closed port or am I hitting a firewall? Hard to tell because a closed port might just drop packets. And they're going to have to do a little more work to figure out whether or not that port is actually open and and a firewall is in place and it's filtering, or if it's just closed, right? So that slows them down, increases their ability of getting caught, right? Or the chances are that they get caught. So just depends on what you want to do and how you might want to work that. Just keep that in mind. All right, let's keep going. Practical examples. Now, I'm using a Cisco ASA, which is something security appliance. I forget, adaptive or application. I forget what ASA stands for, but it's neither really here nor there. What I just wanted to do was show you kind of the rules on how they're set. Let me do that a little bit. I guess I can do a little bit bigger, right? There we go, right there. And that way we can see what a rule looks like. And of course, this only works on Cisco ASAs, but if you're working with any other firewall, it'll be kind of similar. So we've got an access list. Okay, we've built a list. We're calling it outside in. The extended, and this is just an extended rule. What we really want to look at is permit TCP any. Starting right there. Permit TCP any. It's an allow rule on TCP packets of any kind, for anything, any kind of thing that you want to do. Oh, cool. I like it. We're good to go. What's next? And it says host, and it's giving access to 192.168.1.100, and it tells it on service www, which is just shorthand for port 80 HTTP traffic. If you don't like that it's www, you're going to have to call Cisco and complain to them, which is kind of funny that they did that. I mean, I get it. I probably would have went with just HTTP, but they make their decisions and they've got HTTPS, same exact rule, except the protocol or the service that they're trying to connect with. So these are allow rules that are probably going to be a part of a explicit deny type of environment. We got a similar one for SSH coming from a specific host. Or going to a specific host, should I say. So permit TCP any for host 192.168.1.50 on SSH. And again, just a shorthand way of saying port 22. Now we're going to go into some denying, right? Deny traffic from known malicious IP of 203.0.113, right? There it is right there. Deny IP host 203.0.113.5 to anything. I want no access on that. So that's a straight up, do not give this thing any access to this system. If you see IP 203.0.113.5, you drop it on the floor and you kick it and you burn it with fire and you say no. Okay? If we go back into the Windows firewall, we talked about doing a new rule. So I can click new rule and you can see that I can create a rule for a specific program to make a connection or a port on either TCP or UDP. I can use something that's already been defined by Windows itself, or I can create a custom rule, right? And I can go in here and I can say, okay, I'm going to go with that port. I'm going to click next. It's going to ask me what ports do I want and what type of protocols is applied to. Is it a TCP port or UDP port? And I can say, cool, yeah, I want to do like 80 and 443 because I want that web traffic. Or maybe I've got a proxy server that I only want specific people to have access to and I'm running on port 8080, right? Or maybe it's 3389 for RDP traffic. And you'll notice that that is specific to the port itself. If I wanted to make it specific to the program, I would have to go back and say, hey, I want to allow a specific program. Click that next button and then say, cool, what program do you want to run? Give me the path to the executable. And then you would put that in there, or you can hit the browse button, whatever you need. And then it would specifically block or deny or allow or whatever you like to do based off of that criteria. So there you go. That's how we set up rules. Got a couple other things left to go. We did talk about implicit deny, block all traffic not explicitly allowed. In importance of management, you need to regularly review these and update to prevent new vulnerabilities that are coming out. If you've got certain things that were secure before now, but now a new vulnerability has been discovered, you may need to do some blocking of the firewall while you're doing some patching or whatever the case is. You got to stay on top of these things. You can't just set it and forget it Ron Popeil style. You got to constantly be reviewing your firewall rules and allowing and denying accordingly as things change. Okay. Last but not least, benefits and limitations. Here are some key benefits of firewalls. Good takeaways, right? Access control. We can prevent unauthorized access. It can do that and does do that. Threat protection. Block port scans, denial of service, even some malware. Policy enforcement ensures adherence to security policies of our own making or regulatorily. We've got logging and auditing. We provide traffic records for analysis. If there was a breach or an incident, we could use the firewall logs to figure out, especially if it was over the network, maybe we could do some analysis there and figure out who the culprit was. Maybe those are admissible in court, especially if we've taken them in a forensically sound way. But we do have some limitations. It's not a silver bullet. They're not perfect. It's only one layer of defense. It is not a complete solution. Yes, next-gen firewalls can do a lot, but even then, they're still not a perfect solution. We got things like insider threats. Way less effective against them because they have trust. They're beyond the firewall. They're already on the inside. Sophisticated attacks coming from things like advanced persistent threats or APTs, nation-state threat actors, and 0 days where we don't even know how to prevent these things. We don't know anything about them other than things are being exploited and everybody's running around with their hair on fire. We have to look out for misconfigurations. If we poorly configure the firewall, we put ourselves at a major risk because we're putting holes in our firewall, and now it's acting more as a sieve than a wall. We don't like that. We want to stop all the bad traffic, only allow good traffic, and that comes from good configuration. It's real easy to make configuration missteps. And it does not protect against things like viruses within allowed traffic. Phishing, social engineering. You got users, they're going to download things, and they might very well be allowing them to come in. And that does bring up the importance of that egress traffic. If they do install malware, it's going to need to reach out to its command and control. It's going to need to reach out to its threat actor to let it know, I'm installed and I'm doing the things. What do you need me to do? So maybe blocking and putting a better eye on egress traffic is going to be an important factor of firewalling well. That said, we've been through a lot when it comes to these firewalls. Very cool stuff, though. Hopefully you got a lot out of this episode. I hope you did. If you did, you know what to do. Hit that like and subscribe button. Don't forget to bing that notification bell so you know that when we release new episodes, which come out all the time, leave us a comment. Tell us what you like and what you want to see upcoming. Always helpful for us from creating new content, which we do constantly. If you want to know what content's coming out, check out antisyphontraining.com or poweredbybhis.com to see what webinar or new cool thing that we've got coming up. Maybe like things like the Blue Team Summit, the Red Team Summits, conferences, you name it. Plenty of resources out there that we try to make available for you. So avail yourself of them and be better for that. That said, I'm going to call it a day. Thanks for watching. Got more to come in the series. So until next time, have a great day.